see. First time doing one of these. I'm not sure. Is it working? Let's see. Do I not have this right? Shit. I messed it up. Damn it. Alright. I can fix it. I can fix it. Shit. Wait, is it working? I am having technical difficulties. The first time streaming, so if anybody's actually here and you can hear me, I apologize. I'm making sure this works. Do I have me streaming me? Yeah. Okay. Yeah, fix that link. How do I... Can I edit this? Damn it. Okay, gotta try this again. How do I delete? Trying that again. Okay, think I got this set up now. First time live streaming, that's what happens. Let's double check just to make sure. Alright, is this working? Okay. Okay, cool. Alright, hello. I don't think anyone is probably in this yet, but that's fine. My name is Curtis LaGraff. I'm a software engineer here in Michigan, in Detroit. What I'm going to do today is go over one of the daily programmer challenges, 183. Yeah. Let me go to the right page here. I'm going to be using Golang, and the idea is just to kind of try this out, essentially. Try this live streaming thing out. Sounds like a fun idea. I think I might want to do it once a week, maybe, if this goes well. So I figured, why not stick with something easy, something that shouldn't take too long to do, and hopefully it all goes well. So on to the actual topic at hand. So tonight, I'm going to be doing challenge 183, semantic version sort. I'll throw a link into the chat. 1 second. Post. What this is essentially you're going to be given some input, right down here, sample input. That's going to look something like this. So the first line that you have is going to indicate how many different semantic types, kinds, strings, semantic version strings, sure, that we're going to have. It's just going to be in the standard input through the console and not through a file. After that, you're going to have, in this case, 7. So how it works is, given these 7 strings, you're going to sort them using the rules that they have above. Essentially, I think we're sorting them ascending. You're going to sort by the major version first, the minor version, the patch version, the label, and then metadata. So for the label metadata, what you're going to check is you're going to ignore the contents of the label. You're just going to see if it has one. One that has a label is going to come before one that has no label. So as you can see in this example, here I'll zoom in a little bit. Oh, kind of far. You have 2.0.11, 0.1.7, 0.10.7, so on and so forth as the input. Total number of 7. 1, 2, 3, 4, 5, 6, 7. The output in ascending sort, starts with 0.1.7, 0.10.7, 1.2, 2, 2, 2, 20.1, so on and so forth. So again, the first number is the major version, then you have the minor version, the patch version, and then any sort of label, and then what was the, I'm not familiar with metadata. What is metadata? Used to describe build meta when the version is in development stages. This might include a build date. We can just ignore the metadata apparently. Oh, here's how it's supposed to look. Major, minor, patch, dash for label, plus meta. So we can just completely ignore the meta. So let's get started, I guess. So as I said, I'm going to be using Go, so I already have at least a folder set up. Copy some of this stuff. And here we go. Oh. So I do use Vim. I really don't care what anyone else uses. You're more than welcome to use whatever you want. It's just kind of a personal preference of mine that I have. I really like it. Got a good couple of plugins, and it's just what I used for the last year or so professionally. Before that, I used a whole bunch of stuff, but stuck with Vim. All right. So we're going to have our major, minor, patch, and label. So I guess the first thing we want to do is get the number of lines that we're going to have to deal with. So I already I did get started slightly with how I wanted to do this. And on that note, I just want to say none of this is really scripted beforehand, so I am going to be looking up stuff on Stack Overflow. I'm going to be checking out, the Go docs for a lot of this stuff. If that doesn't sound interesting to you, I'm sorry, I apologize. But I really wanted this to be as sort of organic and authentic as possible. So, I'm going to make mistakes. I apologize. I'm going to have build errors. I'm going to have typos, all that kind of stuff pointed out if you like. It's just something that's going to happen. So I'm going to be using this wonderful little thing. So buff.io. Oh, beautiful, auto-tabbed. So we're going to just create a new buffer input-output reader from the standard in. Should have Go imports, beautiful. So I got buff.io on OS. So that's going to get me a reader. I can just read the first line. I don't really care about this portion. Do that. So if error doesn't equal nil, error, not the best, but whatever. Alright, so that line should ideally be a number, so we're just going to use some string conversion because it is going to be a string, I believe. Let's just check real quick. Golang buff.io. And if it is in fact a string, or if it's bytes, we'll just convert it to a string. And once it's a string, we can use string convert to go from a string to a integer. All right, so it was read line, so that returns bytes. Okay, let's do bytes. Yeah, let's throw this in a for loop so we can kind of continue to do this as much as we want. All right, so string convert, parse int, I believe, and that should be line. Again, as I said, I'm going to be going and pulling up the Go docs. It's just kind of how that's going to be for right now. Maybe in the future I'll maybe have this be a little bit more scripted, planned out beforehand, so like some of this stuff isn't part of it. I don't know. It kind of depends on what everyone else wants. I don't really think I have too strong of an opinion, and this is actually what I wanted. Not parse int. So So we'll do num of lines, error, line. String concatenation and go, maybe not the best, not going to worry about it. Continue. Okay. Alright, so that'll give us our number of lines. So I guess we could just do for 0 less than number of lines plus plus. Let's do, I guess I could just continue to use the same reader, I suppose. I don't think there's any reason why I can't. Do that. So I'm just panicking here and 12 lines above instead of just printing out a error message, just because if there's some sort of weird error that actually occurs when I'm just trying to read from the standard input, like, I just want to fail. Whereas if they actually enter something invalid, there's no reason for me to not just let them know. So that's why I'm doing it like that. Alright, so do that. I don't actually need the colon there. Okay, so for I is less than 0, I less than the number of lines, we don't even really need I mean, I guess we kind of do. Okay, I want the current version, I guess. Version. It's bytes. No, it's, yeah, no. Version's fine. And then what is 13 above? That's not how you spell string. Better. Okay, so we're gonna get our version, and it's gonna potentially look something like, this guy here, which I'm gonna just move down for my benefit. So major, minor, patch, label, metadata. We don't care about the metadata. Oh, bump up the font. Sure. 1, 2, 3, 4. Sorry, I have my chat on my other window. I'll try to pay more attention. Is that better for the font size? If it is, just let me know. If it's not, I'll make it better. Also, I didn't realize that anyone was watching, so awesome. Cool. Welcome. Anyways. Alright, where was I at? So, for loop, doing this, doing that, version. Yeah. So, for sorting, what I'm planning on doing is just going to use the sort package and just create an interface for their aptly named interface. And what we'll do is we'll have sort of internal structure, a struct to, cool, glad to hear it's all good. Internal structure to represent the version. So we're going to take a string, convert it to a struct that's going to parse out the major, minor, patch, label, so on and so forth. And then we're going to have a interface that satisfies this guy that'll handle actually comparing however many we have and swapping them and so on and so forth. So I guess we could just start with the struct. Alright, so types semantic version. Sure. Struct. So we're going to major, that should be an int, minor, int, patch, I think, yeah, it's still an int, label, it's going to be string, and then, if I recall correctly, metadata is not important here. So compare the major version, compare the minor version, compare the patch version, we really just need to know if it has a label or not, and then ignore the metadata. Okay. So I guess we don't actually even need to know what the label is. I mean, according to the challenge here, it's just a matter of whether or not it's present. So if it has a label, we can ignore the content. If it doesn't, so I guess we could just use a Boolean to make it has label. And then don't even need to worry about the metadata. All right. Semantic version. So we're going to do that. We're going to do, we'll call it version. All right. So we're going to have just a simple sort of factory function here. So it's going to take in whatever our version string is that we have down here and just convert it to that struct. So we're going to do a little bit of parsing. So I guess first thing, like if there is nothing in it, we really don't care about it. So let's do it like this. So it'll just be default values, which is fine. I guess really though, if there was an empty line, I guess we just ignore it honestly. You'll be given n, and then you'll be given n more lines, each one with let's not even have the check because it doesn't sound like we should ever have that happening. So we'll just get rid of it. All right, let's split it into parts. So to do that, we're just going to use string.split. We're going to give it the text and then the character, which would be a dot. So we can have, 1, 2, 3, 4. I'm just going to do this the simple way. We'll do a switch name, switch len of parts. Shouldn't be 0. So what I've done is, given this sort of structure, major, minor, patch, I'm going to split it by the dot. Depending on how many parts of there are is how we're going to sort of populate the semantic version. So if there's only 1, it just means they only provided the major version. If there's 2, the minor and the major. If there's 3, the patch, the minor, the major, so on and so forth. So 1, first thing we're going to do, it has to be an integer, so we can just use the string convert, that guy, for, spell that right, parts. Am I already using I? I am not. Alright. So we're going to return I don't want to panic in here, so we'll just return an error. SV, and then errors new. Your version must be an integer. Alright, didn't I have another return? Oh, no, that was for the if statement I got rid of. Cool. Okay, so we do that. We can populate this. This isn't a great way to do it, now that I think about it, because then I just have to redo the code multiple times for each part. I guess it would be better to do a for loop over it and just keep an index of which portion we're on. Yeah, we'll do that. For I equals 0, I less than len of parts, plus plus, and then I'll have to fix that variable so I don't have a collision there. That. Let's not use I, we'll do like number, I guess. Okay, so we're going to iterate over each individual part up to the maximum number of parts there could be. In this case, it's going to be 4 or 5, 4 I think. So I'll switch this. So if we're on the first one, that's going to be the major version. We're going to just maybe make this a function just to make life a little bit easier. Yeah. Up here, quick little function, call it parseInt. Oh, one more. I don't even need to do the tabbing. I could just have go import take care of that. Anyways, so we're going to convert this to that and do that. Oops. 0, and then return number, comma. Okay, so parseInt, it'll take in some sort of text that should be a number. It's going to try to convert it to some form of an integer. If it doesn't work and there's an error, we'll just return input must be an integer. Otherwise, return whatever it is. So now down here, we can say major error is going to be equal to parseInt for parts 0. maybe not the best, because like if they do enter something incorrect for a major or minor, I know that it'll just say input must be an integer and not actually say whether it's the major, the minor, or the patch. But for now, we'll just leave it because I don't want to get too bogged down. Alright, so we have parts. We're going to iterate over each individual part. If we're at the first one, it's going to be the major version. So assume there are no errors, then we can populate this. So major is equal to major. Cool. And then basically that kind of stuff for, undo. Same kind of thing for the minor and the patch. Yeah, we'll keep going. Yeah, I had a thought that I'm gonna come back around to in a second. Minor. Is that how you spell minor? Hold on, real quick check. Yeah, okay, it just looks weird. It's one of those things where, the longer you look at it and you spell it out, the weirder it seems. Alright, so we got that. This could be patch. So for those who are familiar with the Daily Programmer Challenge, it's not necessarily like a rule or anything, but a lot of the submissions are as minimal as possible. They're trying to have like as few bytes of code as applicable. Not exactly what I'm going for here. It'd be an interesting challenge, but for now I'm just trying something simple of just making a script that satisfies that challenge and call it a day. So for those who are thinking like, oh god, this is large and there's so many different optimizations, like there's plenty. I'm just that's not really my goal right now. So major, minor, patch, and then this would be, so major, minor, patch. Okay, so the patch doesn't have a dot delimiting the label, it just has a dash. So what we're gonna do is modify this slightly. So what we need to do is try to split that, I guess. So patch parts. By dash. Patch text. We'll do it that way. Alright, so that'll give us just the patch number, and then we can just check the length to see if it's 2 to determine whether or not we also need to, if we have a label, essentially. Perfect. Minor is how it's spelled. Thank you, Evan. God, I really need to get like the chat on my phone because my screens are so far apart. I'm gonna miss everything anytime someone types anything. I'll worry about it next time. Okay. Shit. What was I thinking? Oh yeah, the label. So I'm gonna get the patch version itself, and then for the label, if we have parts, we'll just say greater than 1. It really should be equal to 2, but whatever. Then we're just gonna do sv.hasLabel equal to true. Don't even need to know what it is. The other thing that I want to make a change to, so that's all fine and dandy for how our struct's set up for major, minor, patch, and hasLabel. The problem is when we do the output, what I don't want to see is a whole bunch of, like, if they put in just 1 for the major version, what I don't want to do is have 1.0.0 because we have 0 values for these other 2 integers. So what I'm going to do instead is just have the original text that they provided. That way it also has whatever the label was, and it also has the metadata, and that's what we'll print out. We'll just sort by the major, minor, and patch attributes here. So we'll have original text, I guess, call it a string. Original text equal to version text. Alright, so let me make sure all this is somewhat sensible. So we're going to have a function that's going to create a new semantic version struct based off of some version text that we provide. Very first thing, the original text is just going to be inserted right into there. After that, we're going to split it on the dots, which delimit each kind of version. Based off of the current index, whether it's 0, 1, or 2, we'll determine whether we're updating the major, the minor, or the patch. Major and minor are very obvious, like code makes sense. For the patch, we also have to check and see if it's got a label affixed to it. If it does, we're just going to handle that by just setting boolean to true. If it doesn't, it'll just be 0 valued to false. So I don't need to have that else case because it's going to be false by default. And that seems moderately fine. So I guess we can probably return. Maybe see where we're at. See if we can just test this out would be nice. So we're going to get this. So let's do just keep with SV. Yeah, we'll just print out the struct. So let's see if that even builds. That'd be nice. All right. So fixing a couple issues. Original text. Misspelling. Original text. All right. Patch parts. Oh, parts. Okay, so that's spelled wrong. So patch text, and then I need a colon. Spelled with an I. That is a bad habit that I need to get out of. Okay, so let's try. So let's do like 2, and we'll do like 1.0.0. Okay, so not quite. 2.1.3. Alright, so it's at least getting the original text, but something's not quite right, so let's figure out what's wrong with that there. Alright, so we're definitely getting the right version text. That's getting in there correctly. So is there something wrong with our parts? I don't think so, but it's easy enough to check. 1.2.3. Okay, so we're definitely getting 3 individual pieces of information. Oh, I'm doing it here. That's stupid. Do it on I. Okay, try that again. Okay, that seems a little bit better. Let's try 1 and then do 3.1.2 dash foobar. Okay, 4.1.2. It does have a label, foobar. Okay, perfect. So it looks like that's working fine. Let's see. I don't. Let's get rid of this outer for loop. I don't really want that. Whoop. Yeah, that's fine. I thought I wanted that outer for loop, but I don't really want that outer. I don't really want it. Okay, so we'll do 3. So we'll do 1.1.0, 2.5.1, or 3. Let's do like 11, 50. Okay, and X. Perfect. Cool. All right, we have that. That looks like so it's working very nicely. So what I want to do, as I said, is use the sort interface. So we're just going to create a struct that has some methods that satisfies this guy. In fact, I'm just going to copy it over. There we go. Let's not put it right here, though. Let's move this down. Type version container, I guess. I don't know. I don't want to get bogged down in names. It's not even a struct. It's just gonna be a slice of. There we go. All right. So len's got to return int. I don't know why I did ass there. Alright, so we have our pointer, or our function receiver, which is just an instance of version container. We got len, int. We're just going to return the length of it. Seems fine. So now we need less. We'll come back. Yeah, we'll do it now. Yeah, sure, why not? VC version container. And that should be just what? I and j for an int. Yeah. Oops. I, j, int. Cool. So this is supposed to report whether the element with I should be sorted before the element with j. So the Boolean is just going to be true if I should be before j. Okay, that's fine. So let's get our two elements. So first is going to be VC and then whatever I is. Second is going to be VC at j. So now we need to break it down. What would be the best way? So I could just do a whole bunch of if statements. So like if, first dot major is greater than second dot major, so on and so forth. If first dot minor is greater than the second dot minor, so on and so forth. Could do it that way. I guess I could just iterate over it. Let's just make it work first, and then we can get fancy with it. So first dot major, is greater than second dot major. So we're supposed to be ascending for this challenge, right? Yeah, so we'd go 0, 1, 2, 20, so on and so forth. So if we're reporting whether or not I should be before j, that's really if the major version is less than the second one. Oh, lowercase. So if first dot major is less than second dot major, then we return true. Same thing for the minor version. Catch. Whoops. So for the label, what was it? If everything is the same for the major, minor, and patch, check if it has a label. But we can ignore the content. Version with a label comes before one without one. So if has label is equal to true and second dot has label is equal to false, return true. So if they both have a label, then we're just going to treat them as if they're entirely equal, and just whatever one is inputted first at that point in time will be the one that's listed first. Whereas if the first, sorry, I know I'm already using first, that could be confusing. If a version has a label and the one it's being compared to does not, then the one that has a label will be higher up on our list. It'll be preceding it. Otherwise, we're just not going to care, and just however they inputted it at that point in time is just how it's going to come in the ordering. All right. Oh, is this caffeine free? Damn. Well, whatever. And then ignore the metadata. Okay, so otherwise return false. So if first dot major is less than second dot major, true. Can we just return false right there? I might have gone too fast and didn't really think that one through. Okay, so if we had two versions, let's say 1.0.0 versus 2.0.0, it should be that 1.0.0 becomes before 2.0.0. So if 1 was less than 2, we return true. That's fine. If it was the opposite, then it would simply be false. Okay, yeah, so I'm just missing my else's. Okay. So I can just do it that way, and then I don't have to bother with an else because it can just go on. Okay. All right. So, and then if that one has the label and that one doesn't, I guess we'll do the opposite. If well, I mean, in this case, I would just return false anyways, so I really don't need that statement because I'm going to return false at the end of the function anyways. Cool. Oh. Yeah, that's not how you spell that. Okay. So we have the length, the less, we need swap. Does that return anything? I don't believe it does. It does not. I can't remember. Does Go support? I don't think it does. I think I do need to do it like this. All right. So yeah, that's everything for that interface, I believe. So get rid of that. And we can populate this guy. So we're going to need one of those containers. So we'll do container is equal to version container. So we can append into that now. What was it? VS. All right, so ideally we would populate our container for however many different versions we enter, and then at the end we need to sort it. So how was that done with this? Now that I satisfy this interface, let's see. Search, slice, sort. Okay, sorts data, Okay, sure. What package is this? This is sort. So that should sort it, and then for version, I guess. Did I already use that? We'll do. Who cares? It's outside the. It's the only thing is that so I already defined version up here. I know it's in the scope of the for loop, so it's not like it's a collision. I don't like having these things named the same, but I'll fix it later. For each one of these in the container, we just print out the version.original text. Let's see if that. Oh, range. Let's see if that works. All right, so we'll enter 3. We'll do 2.0.0, 1.0.0, 3.0.0. Okay, so that seemed to work. Let's use their input. What did they have? All right, so they had 7. So 2.0.11 dash alpha. Whoops. Oh, 2.0.11 dash alpha. Oh, because it wasn't a dash, so it got mad. Okay, I'm gonna have to fix that. So I just ran this in case it wasn't obvious. I had a typo where it was an equal sign instead of a dash, and then it errored, strangely enough. The reason why it errored is because our code checks explicitly to see if there's a dash, a subtraction sign right here. But if there was metadata, which would be with a plus sign, if I'm not mistaken, plus sign, then it wouldn't work because it'd get upset. So I need to do that. I really could just get rid of it. want to do this? So I don't need the metadata, so I can just ignore it. So I guess I'd really just want to, if there is a addition character in there, just remove that and everything left, I guess. It'll be easy enough. Okay, so we'll just use a string package for, I think it's what contains or index. Is this what I want? Returns the index of the first instance of the separator. Okay, so alright, let's use that then. What does that return? Just, yeah, index. So index could equal to the strings that index for the patch text, and then that, whoops, no, that, there we go. So we want everything up to that. So I guess could just be the first character. We'll take care of that in a second. We can just continue then. Okay, so I think that should fix the problem. If you inputted anything that wasn't either for the patch text explicitly, it wasn't either a a number and then a dash, or a number and then a plus, or a number and a dash and a plus, then you are going to still get the error. That seems like that's fine, because there was no indication in the challenge that you should do anything other than that, and that definitely anything that doesn't fit those couple of patterns, doesn't fit this pattern. So I think that's fine to just error there. So making sure this makes sense. So we're going to have patch parts. We're just going to split it by the minus sign. If there was more than one part, then we know that it has a label, so we can set that to true. Then we can get the patch text, which is just going to be the first element. From that, we're going to check and see if it has an addition sign in it. If it does, which means that it wasn't -1, then first, if that was the first character, then there was no patch version. It was just, a plus sign. So, for instance, it would be like 0.0 point plus, metadata, which I'm not even sure if that'd be valid or not. Thanks, Evan. Happy to hear it. Yeah, I'm gonna maybe make this a weekly thing because it's fun, and the best way to learn is to try to teach. So I'm glad that you got some enjoyment out of it. Hopefully others do as well. Have a great night. Thank you. Yeah, so 2.0.metadata. Not even sure if we want to consider that valid or not, but I'm not going to error just yet. Maybe we should. I'm gonna not worry about it. But point being, this will take care of that condition. Otherwise, we'll just get everything up to that index. So if it was 0.2.1 plus meta, it would just be 1 because we'd get everything up to that character. So that would take care of that. So let's try this again. So we'll enter 3. We'll enter 7 because that's how many you're testing over here. Alright, so we're going to have 7 of these guys. Whoops. Hit refresh. So this is the first one. And our second one. And our third one. Fourth one. I don't know why I'm counting, because I know you guys can as well. And one more. Okay. Geez, I really should have some sort of dash. Okay, so starting here, that's good, that's good, that's good, that's good. Did I miss one? Hold on. So 2011 alpha, 2011. That's not quite. Do I have my condition wrong? So Why did this guy come after that one? Looks like maybe something's wrong with the patch. Alright, so in our less method on our version container, first.patch less than that, true, otherwise return that. That should have, I don't think that's wrong. Unless I'm missing something. Because it'd be 11, and then 11, and then 12. Right? I'm not crazy, am I? Alright, first off, that's gonna bug the shit out of me. Let's fix it. Let's throw some sort of at least then we'll get a little bit of spacing. Yeah, just run it again real quick. Can I just copy paste this? That'd be really nice. No, guess not. Here, we'll just do the ones that are important to us. So we have this guy, this guy. Wait. Oop. Maybe that was, did I not type, where's this? So 2.0.11. Oh, did I not type that in the first time? No, that's right there. Okay, I don't know. I'm getting myself confused for some reason, and that's starting to bug the shit out of me. So I want this guy right here. Come on. Patience is a virtue. If I just type it a little bit slower. There we go. Okay, so we got that guy, and I want this guy. And I said 7. I really want 2. That guy. That guy, and this guy. Just these 2. Okay, so that gets sorted out correctly. So let's try it with the 12 as well. So we have this one. We have this one, and we have this one. Why the hell is the 12 one coming out? All right. 2, 0, 11. 2, 0, 12. All right, well, let's throw some print statements in. I'm not really sure quite what I'm doing wrong, but I'm obviously doing something not quite correct. So let's print out some debug stuff. All right, so we'll print out those 2, and then I guess we could just do okay. So we're gonna have 3 of these. So we're gonna have this guy. We're gonna have this guy. We're gonna have this guy. Okay. So first we compare 2, 0, 12 with false to 2011 true. So that'd be this guy. So we're comparing this one and this one together. So it should return true if this guy should come before that guy. And we obviously know that that's not the case because the 12 should come after. So we get false. So that's fine. And then we get 2011 false. That guy against this guy. That should have been true. And I didn't make my return statements a whole hell of a lot better. Alright. I need to make this slightly better. Let's just throw some shitty text in here. I just got to make sure that I know where this is returning exactly. Oh, God. Having to type this again and again is really starting to piss me off. I should have just read it from a file, but whatever. I need to get a USB hub so I don't have to. So I have my USB mic plugged in, and then I have a USB keyboard plugged in. And, okay, interesting. Alright, let's just throw random text into all these. I think the issue is right down here. This is where I think the problem's at, but we'll see. So we got this guy, alpha, and this one, 12, and then the normal 11. Okay, so yeah, it's right down here. So I think there's a problem then with something. So this is where we're hitting the sort portion, the less method. So it should be checking first the major versions, so those are both equal to each other, so that's fine. It should check both of the minor versions. Oh, son of a bitch, right there. Patch. Whoops. Copy that over and have some pasta. Okay. I'll leave the returns in there for right now, but shit, I cleared the console. Okay. But I think that's gonna do it. Alright, so we're gonna have this guy. And we're gonna have this one. And we're gonna have this one. Oh, no, all the way. There we go. Perfect. Okay, now I think it's gonna work. So let's get rid of those print statements. Okay, going for the gold. Here we go. Oh yeah, I need to buy a USB hub. I do not like having my hand over here on my touchpad while I'm trying to type and move all this shit over. Need my mouse back. Oh, you know what? I've got a Bluetooth one. Why don't I use that? I should have done that. Whatevs. Okay. Moment of truth. Does it work? 017, 010, 1, 2, 3, 4. We got our alpha, I36, our 12, and our 20. Yeah. Oh, cool. Yeah, alright. Pretty good. So we can't do the overload or the comparison, so that doesn't work. We don't need to make our own quick sort, so that's fine. Yeah, looks like that's good. All set. All right. That's basically it, folks. For anyone still watching, I'm going to do a little bit of cleanup, add some comments in. Just I like to have good, clean code, so I'm going to go through that. So you're more than welcome to stay if you want. If you don't, totally cool. Great having you here. And I don't want Facebook statuses popping up. Yeah, all right, very cool. Just gonna add some comments and then call it a day. All right, so for those unfamiliar with Go, you basically have two kinds of sort of functional units. those that are so that all right, that's a very absolute statement. Let me rephrase that. You have you have a single way of making a function available outside of your internal code. So if you have a library and you want a function publicly available to things that want to interface with that library, basically you just have to make the very first character of your function or your method or of your struct uppercase. So if it's lowercase, it's internal. Because of that, technically, I could get by without having any sort of like doc strings in these internal functions, because who cares? It's not going to be so, because they're private, they won't show up in the Go docs. It'll only be stuff in the source code, so you don't actually have to really have it documented for other people's benefit. Other people's. I mean, obviously, if you work with a team or it's more than one person or seeing yourself, like should always document it, but I'm not really going to worry about it. That was a lot to say, just to say that I want to be lazy. Semantic version. The semantic versioning value, I guess. Sure, we could do that. So I guess what I'm thinking is, do I want to keep this as make semantic version, or do I want to just... So that's not what I want. Let me rephrase that. Do I want to keep this function, this make semantic version, as it is, or would I rather just make this a method on semantic version and call it like parse or something? I think I'd rather do that. Yeah, all right, let's do that. It's minor, it's easy, and it'll make me feel better. All right, so here's why I'm not going to do that. So I'm going to keep make semantic version as it is and just document it. The reason why I'm not going to convert it to a method on semantic version is because in order to actually modify the properties of semantic version, I'd have to make its the method essentially operate upon a pointer, because that's the only way I'll actually be able to modify the attributes and have that modification stay. So like the function signature would look like this. Something like that. And then obviously right there, the little asterisk is to indicate that it should be a pointer. It's not like it's a problem. That's totally okay. There's no real reason for me to bother creating a pointer to it, then calling parse, dealing with an error, etc., when I could just really just have it be part of make. So I'll just leave it as it is. Oh, need that Oxford comma. God, I know this isn't Grammar 101. Who gives a shit? Takes a semantic version text representation, parses the text into its individual parts. We'll just rename it to that, into its individual parts. And returns a populated semantic version struct instance. Individual. It looks weird, but I think it's about right. Okay, so we do all that. Not going to bother commenting on any of this right now. I will make one mention in here. Alright, just saying, the metadata is totally ignored. Because it is. Okay. Version container. Sure. Okay. Cool. Semantic version. Indices I, J. Kind of weird phrase. I'm sure there's a better way to write the doc string, but I'm not really going to care right now. Swap. All right, and that's it. Just real quick, one more check. I'll just do something simple. 3.1. Let's do. Cool. All right. I mean, I'm sure there's more that we could do here, but I think that's good. So 10:30. I think I started this at 9:30, so about an hour to do an easy one. And I'm pressing buttons I didn't want to press. Hold on. All right, so it's more code than you probably need to do it, but like, whatevs. Yeah, okay. I think I'm gonna call that a night. Honestly, this was kind of fun. I don't think there were too many people tuned into it this time, but that's okay. Today's Saturday. I think I want to do maybe a couple of these a week. I mean, honestly, if I stick to easy ones and it only takes about an hour, I think that's very doable. So I guess be on the lookout for more next week. I'll try to schedule them beforehand and make sure enough people can see them. And thank you for tuning in for those who did, and for those watching this in the future. Great to have you. Feel free to leave a comment or whatever. You're more than welcome to get in touch with me. If anyone has any ideas of what I should do next for my live stream, please feel free to let me know. It's my intention to probably continue going through some of the daily programmer challenges. It's very good form. It's very simply structured question. It's got a good deliverable, good goal to go for. It's got example input and output, and then there's so many people who respond to these usually. So if we ever got stuck just in the sort of general idea phase for how we want to solve it, we'd have a lot of material at our hands to do so. So probably stick with that. I'm rambling on. Thank you very much for those who tuned in. For those who are watching in the future, thanks for watching in the future. Have a good night, everyone, and hopefully I'll see you sometime soon. Bye-bye.